All right, thank you very much. Well, thank you for joining us today. We are going to take a deep dive into blockchain, some interesting applications, Appian's blockchain plugin, as well as some examples of different blockchain applications. So if you were here for the developer innovation, hands-on innovation lab, stick with us. We're going to go into some new content. The first couple slides might look a little bit familiar to you, but I promise we'll get to some interesting and juicy stuff here. So, I'm sure you've all heard of Bitcoin and Ethereum and maybe some other cryptocurrencies. And blockchain actually does make a very good distributed ledger, where in a traditional banking system, you have a central clearinghouse that's a single point where clients can go and access their information to see their account balances. And then all the information is hidden behind the clearinghouse's walls. So they can define who can see what, and when they can see it, they control when transactions occur. What happens when this clearinghouse goes down, or they are hacked? If this happens, they have to this entire application, this bank or enterprise is completely down, and no one can interact with the ledger because it's either gone or completely destroyed. And it might be a really expensive process to go through and rebuild this ledger from paper records or backups, or maybe it's lost forever. And so having this central point of failure is really what the blockchain distributed ledger was meant to solve, where if you lost, or basically in a blockchain, all of the nodes in the network contain a copy of the ledger. No one single authority controls the entirety of the information. Rather, the information is spread across hundreds, thousands, even millions of nodes. And so, if that one point of failure is taken down, hacked, or if that's the person running that blockchain node decided, I'm going to try to give myself $1 million, the rest of the network will be able to decide, everyone else agrees that that is not the correct information. We're going to exclude you from the network, or we can continue on and functioning without the rest, or without that single point of failure. And so it gives you a system that allows these points of failures. And so you have a lot of redundancy in the blockchain network. And so why would you choose to use blockchain? Well, like I said, there's a disintermediation. There's no single point of failure. And you really are able to break free of this model of a single entity controlling all of the information. Imagine for a moment that we're looking at eBay. eBay allows you to connect buyers and sellers of random stuff on the internet, and you can go in and make bids, and then they will protect both the buyer and the seller from fraud. And so this basically allows you to have a system of trust that when you make this financial transaction, that you're going to get goods in exchange, and that the goods that you're shipping out, you'll actually get payment in return. But at the end of the day, if you have ever sold anything on eBay, you'll find that after eBay takes its tax and PayPal is taking its tax, you're cutting into up to 20% of your profit margins, which is an incredibly large piece of the pie. Blockchain allows you to essentially have the benefit of a system of trust while the technology itself is acting as this third-party escrow, or essentially providing that system of trust with two independent parties. And so you can definitely see a great cost reduction in your operations by using blockchain. You can also have greater accessibility, as you don't necessarily have one single node sitting on AWS Virginia, but you rather have thousands of nodes spread across the entire planet, and you can communicate with any of them to access the application. You can also have more transparency. Let's say eBay wanted to increase its profit margins. They could go in and create fake accounts and place phantom bids, and so they could actually just max out the price on every single auction, and then increase their profit margins. And no one would be the wiser, because they are in control of all the information, and they can create these accounts without your knowledge. With blockchain, no one could do that, because everyone can see everything that happens in the network, and so every transaction can be viewed. And then you also have trust through cryptography. Through the structures of blockchain, you can actually confirm that the information being shared came from a very specific source. So eBay can't just go and say, oh, well, you sent these messages that they created. They actually are, by using the blockchain, you can actually cryptographically sign every single message and confirm that the information you're receiving actually came from who you thought was sending that piece of information. And then finally, it's also in really high demand. Blockchain was the most searched term by our clients in Gartner Research Portal in 2017. So it is very hot right now. So the thing about blockchain, though, is that a lot of people just think Bitcoin. As soon as they hear blockchain, it's just synonymous with this idea of these cryptocurrencies, these ICOs, and all the hype and buzz about making blockchain be the distributed ledger in the future of banks. But in my personal opinion, this feels a lot like taking the early days of the internet and finding email. This is going to be the future of the internet. That is all it's ever going to be for. I mean, email is a great application. It does a lot of great things. I can send messages back and forth. It's really a great application of the internet. But imagine if we had just stopped there and decided, the internet is only for email, and never got to see cute cat photos on the internet, YouTube videos, e-commerce. There's just so many other applications of the internet. And much in the same way, blockchain can be used in so many other ways through what's called smart contracts. So smart contracts are very similar to paper. Oh, I apologize. Go back one. All right, so smart contracts are a lot like your typical paper contract. It outlines the rules of engagement, who owes who what, and basically allows you to define exactly how the transaction will occur. But with any paper contract, you need a central authority to say that this contract is, one, valid, and two, that the central authority will maintain and punish people who don't follow through on their contract. So whether that's a bank or the government, and so basically, you need this this authority figure to say, okay, we actually need these things to happen. However, with blockchain and smart contracts, these contracts are actually their own authority, and so they can actually execute themselves. And so if certain criteria are met, such as maybe transferring a title of a car, as soon as payment is received onto the smart contract, the contract will execute and automatically change ownership of the vehicle and make sure that the person who originally owned the vehicle receives their funds. So why aren't we already using blockchain today? Why hasn't every company just jumped on this bandwagon? Well, honestly, the blockchain apps are pretty hard. It takes a lot of custom app development. It's a new and growing technology, and so there's, of course, few experienced developers. So it does take time for us to really start seeing these rich blockchain-backed applications. This is, of course, where Appian can come in. So using Appian, you can interact with smart contracts and have a blockchain-backed application without having to go and train your users how to rebuild or how to use a wallet, how to use all these complex topics, and possibly lock millions of dollars into the blockchain network, which has happened, unfortunately, too many times because of poor programming or poor user training. Using Appian, you can use programming paradigms like SAIL, rules, processes, and integrations, all in the way that you're familiar with. And so therefore, you don't have that same friction to ramp up on your blockchain application. So just to walk you through some blockchain use cases, as I had said, you could use it for property registration. You could replace traditional paper titling of houses and vehicles, which could be duplicated and forged. And you could have it as a digital contract on the blockchain where you could own a vehicle digitally, and no one can take this and copy it or say that they actually do own it. And you can have that complete transaction history without having to go to a bank or a DMV or a central authority to see the transaction history that happened on this vehicle. And of course, you could do document authenticity. Use cases like this could be used for transcripts, where a university could go and publish all of the registered students at their university, and then just have a hash of the value, or hash of the transcript. So when a student passes along or emails over their transcripts, rather than going to the university and asking, oh, is this certificate or this transcript valid, the company could actually just hash the file and make sure that it hasn't been photoshopped. And there's plenty of other examples that we unfortunately don't have a lot of time to go through, but essentially you could basically build any modern day application through blockchain. The biggest need, or the biggest requirements for these applications, is just a method of authenticity, making sure that the people who are as part of the transaction are actually authorized, and also having that level of transparency or just security, and not being able to have these documents tampered with. And so yeah, you could also do all the financial stuff, such as Bitcoin as well. So I'll hand this over to MC.
Thank you, Austin. So the requirements for blockchain. You need to have at least two parties. They need to be able to. They need to have the need to interact with each other, and they need to not be able to trust each other in order to perform that interaction. That's the perfect storm for blockchain. There's been a lot of churn in the blockchain world, not just over the past 10 years, but even over the past 5 and over the past 2 years, and it'll continue to be churn over the next year. And that's happening for a couple of key reasons. By far, the most notable name in the blockchain world is Bitcoin. It bled even outside of the tech industry last year as financial speculation went wild, and I even had friends approaching me in as late as November, should I invest some of my savings inside of blockchain? And of course, we inside the industry knew that that question was absolutely phenomenally a bad one. But by far the most popular blockchain on the planet. The one that we've been dealing with quite a bit with inside of Appian, and the one that's behind the scenes in the demo that we'll be showing today, is Ethereum. It's taken the concept of a distributed ledger, which is the underlying technology behind all blockchains, and has put, of course, on top of it smart contracts and digital applications, distributed applications, or dApps. What this is the ability to perform certain types of transactions given certain rules, certain conditions, and this lives on the blockchain, on all nodes on the blockchain. The third most popular blockchain, been around since 2012, is the Ripple consortium. It is a cryptocurrency like the others. The cryptocurrency is actually called XRP. And in addition to being able to, I filled out real quick. In addition to being able to trade XRP amongst participants in the network, you can actually trade anything, any commodity, a stock, real world currency, anything that actually trades value. Now, Ripple is an excellent example of an industry having a need and modifying or innovating on top of blockchain in order to address that need, over and beyond what Bitcoin and Ethereum already offer. How do you trade a real world item on a blockchain? It's easy to do it with cryptocurrency because the value that everyone has inside of that network is defined by the network itself. It's defined by the ledger. But they said, well, we need to be able to trade items that exist in the real world. In order to do that, in order for me to sell something to someone else, they need to trust that I actually have that item. And so what Ripple did was they said, we're going to have the concept of issuances. Issuances are going to be private data between two or more parties, and the issuance will not be validated. It will not take effect unless both parties signify that they agree to it. That means that party B essentially gets to say, yes, I trust that party A has 3 blocks of gold to begin with, and then it'll be traded to me. Now, Ripple's mostly used in the financial industry by banks around the world to actually trade currency between themselves. And so they're able to do that, but do it at a lower fee. So I filled this out prematurely, excuse me for that. The fourth one that showed up was Hyperledger. We'll be going into some detail about this today. This is actually a cross-industry effort by the Linux Foundation, as well as a consortium of other companies as well. The specific specific design intent, excuse me, of Hyperledger is to form a blockchain around the needs of the enterprise. And not just technology companies, but we're going to see in a little while, they're actually a consortium of different types of companies from multiple countries and companies that operate in multiple countries. How can we truly bring blockchain to the masses and to the needs of the enterprise? So, what are some of the considerations that you have to think about when you're considering either public or private? Neither way is necessarily good or bad. It's just a matter of what you want to get out of your experience. Public blockchains have higher availability because anyone can take part. That means that you're going to have the highest number of participants, and that means that that network is going to be the most resistant against any sort of attack, whether it's an attack on the network itself, whether it's a totalitarian country shutting down the internet connection inside of that country, and these things are real, they do happen, as well as transparency and trust, because you may not know who's transacting, but you can see all of the transactions. It's just there for everyone to see. And then, of course, with the public blockchain, you have no hardware costs. All you need to do is transact against it, but you don't actually need to run hardware in order to support it. Private blockchains are becoming more of a consideration for a number of reasons. Overall, there's going to be a lower cost to operation, and actually, when we go through some of the networks, we'll talk about what those lower costs to operation are. But for example, it's very expensive to run Bitcoin, and as a matter of fact, I knew that I was going to include this in the conversation today because I just read this article last week. There was a gentleman who broke out of prison in Iceland. He escaped on a plane to Sweden that also happened to have the Prime Minister of Iceland. That's incidental. He was in prison because he stole a little over $1 million worth of computing hardware and set up a data center in Iceland to mine Bitcoins. And he did it in Iceland because they run on geothermal and electricity is cheap there. What that means is it's such a consideration, the amount of money that it takes in order to run a data mining center and blockchain, that he was even willing to steal machines and go to another country to do it there specifically. So there's a high cost of operation to some of these blockchains. But there are pros to both as well. Blockchain is a decentralized network, which means it's going to be resistant to attacks. It has a synchronized ledger across all of the networks, so no one node going down is going to cause you to lose that data. Everyone has a copy of that data, and of course that data is guaranteed to be immutable, or read-only, or fixed for the life of the time of that network. So why Hyperledger? As I mentioned before, it's led by the Linux Foundation as well as a consortium of companies. I included some of them up here, and that was to show that these aren't just tech companies. Industry as a whole, global industry as a whole, is trying to figure out how to best take advantage of this technology. So it's a cross-industry effort. We have finance, FinServe, we have airplane company with Airbus. Of course, we have a number of tech companies. We have companies that not only exist in different countries around the world, but that operate in different countries. And what is it that the enterprise needs in order to best leverage this technology? So Hyperledger, like blockchain, like Ethereum, is a distributed ledger technology. It was made with the specific purpose of figuring out how to use this in enterprise, how to leverage enterprise governance and controls, and specifically how to address enterprise needs. It also wanted to make sure that it could limit participants. And this is something that I've been talking to some industry folks about for the past couple of days. So for example, with Ethereum, you can limit participants, but typically you need to do that at the network level. Right? So you need to spin up your own private Ethereum network. And organizations seem to want the flexibility to not only have a permissioned or restricted network, but within that network to have private conversations or to limit the visibility of those conversations. So there are a number of technologies that are coming out of the Hyperledger effort. Hyperledger Fabric is probably going to be the most notable of them and the most popular. It enables competing business interests, at the same time allows confidential transactions, but like I said before, on the same network. So one of their specific intents was to create private channels that were used for communication. So I need to be able to collaborate with 50 businesses that are out there. I don't trust them, and I don't necessarily trust the data, which is why we need the blockchain. But I do want to be able to transact and not necessarily have everyone else see what I'm transacting and with who, and that's the point of private channels. So here we get a robust network through increased participation, because we don't have to limit our network just to the people that we want to transact with and have see that data. We can have more participants and privacy for our conversations. We have a trusted group of participants through participant control, and then we have an even greater network robustness and visibility because we're able to have more participants without compromising on the security that we want. Hyperledger Sawtooth, and by the way, Fabric was spearheaded or led by IBM. Sawtooth was spearheaded by Intel. And it's been actually adopted. I'm not sure if it's a standard, but heavily used by Huawei and by Amazon. So obviously two companies whose names come with a tremendous amount of clout. A couple of things set Hyperledger Sawtooth apart. One is the consensus algorithm. And we haven't talked too much about that just yet, but I talked about how Bitcoin requires a lot of energy, and that's because in order to create consensus about what new information should be introduced into the ledger, they do something called proof of work. It means that when information is added, everyone's given a really, really, really hard problem to solve. And the first computer to solve that problem gets to say, here's what the new additions to the ledger should be, and by the way, I'm going to be rewarded with some Bitcoins, or in the case of Ethereum, with some Ethereum. Hyperledger Sawtooth wanted to take a different direction, and it's because it didn't want only the strongest computing resources, or the folks of the companies with the strongest computing resources, to be able to make a meaningful impact and be a meaningful participant in a blockchain network. And so what they did was something called POET, or proof of elapsed time. In proofs of elapsed time, when there's an addition, everyone's assigned a random number, a random value. And this is the time that they need to wait before they raise their hand. And the first participant to raise their hand is the one who gets to say, well, here's what the next addition should be. And in both cases, proof of work or proof of elapsed time, whoever wins, they say, here's the addition, and then everyone else validates or ratifies so that there's consensus across the network. So the reason we went with Hyperledger Sawtooth was, maybe we can have IoT devices start to contribute to this. Maybe mobile devices start to contribute to this. Right, but those are devices that traditionally have limited computing resources, so proof of work just doesn't make sense in those environments. By the way, one additional item about Sawtooth, the smart contracts. It has smart contracts just like Hyperledger Fabric, just like Ethereum. But in the case of Ethereum, you have one language that you can code in. It's called Solidity. And if you've ever programmed in one of the latest languages before, one of the latest object-oriented programming languages, you basically understand the coding. But Hyperledger Sawtooth allows organizations to code these contracts in Go, JavaScript, and Python as well. Why is that valuable? Because Solidity, for all intents and purposes, is a new language. But I'm an organization, I already have resources trained in one of these languages, right? So we have a lower ramp-up time if someone can code in a language that they already know. Hyperledger Indy is the brainchild of an identity management company called Sovereign. The goal of Hyperledger Indy is to provide digital identities to users. So we want to give them the power to share their identity with whomever they choose. It's similar to what we might do with Facebook or LinkedIn when we're logging in and we want to use them to authenticate and give us our identity. But it's precisely the opposite in terms of risk. And that's because when data on this blockchain is no longer needed, it's expunged. And so one of the things that we were talking about, even as we were planning for this presentation, and that actually the industry has noted, is what if Experian a couple of months ago had been using something similar to this? Even if they had been hacked, there would be no data to hack, or at least there would have been limited exposure and fewer people's information compromised. So that's why they're doing that, and I think there's a tremendous amount of value there. Hyperledger Aroha. There are a number of other efforts going on. There's Burrow and a couple of others, but I wanted to include this to show the diversity of intent that's trying to be addressed here. So this blockchain is designed in C++. It's specifically intended for mobile development environments, and it uses yet another consensus algorithm called, big word, Byzantine fault tolerance. Why do we need another consensus algorithm? This one specifically is one where there's one entity inside of the network who is tasked with saying what the additional data is going to be. And then everyone else just votes, is this correct or is it not? But the idea here is, again, we want to get away from proof of elapsed work, because that's primarily going to be energy intensive. In mobile environments, that's going to be battery intensive. And now it's time for the demo. Go for it.
Thank you, MC. All right, so let's go over to the demo here. So we, as Appian, created an Ethereum plugin, which will allow service centers to essentially have a registry of vehicles, or to allow a centralized registry to maintain vehicle VIN numbers as well as their entire service history. So essentially replacing Carfax. And so in this registry, Carfax can authorize service centers to provide transactional data, which will propagate this information to the blockchain. And so with this Ethereum plugin, I'm actually going to go through as a new technician and add myself as an authorized user to my service center smart contract. So I'm going to first create my wallet, which is the only new component that we have to see in order to perform these transactions. As I had mentioned before, in blockchain, every user has a unique identity. This allows them to sign that transactional data, in this case, be able to say that when I add this new service event to the registry, this actually did come from me. And so the entire network can know that this did come from an authorized user. So I'm going to first just create my new wallet. And so all I have to do is create my wallet, and now I have a new wallet. I hit submit, and now this is attached to my user account within Appian. Now, if I were to go over to a manager who is already a manager is authorized to go in and add new technicians. So I'm going to go over to the Add Technician page. I'm going to search for my new technician. And I can see that technician's wallet address, which is their unique identifier. I can see that they are not currently a technician on our smart contract. And then I can also sign this transaction, which will allow me to authorize this user to perform transactions on behalf of my service center. So after I unlock my wallet, I can then sign this transaction. So every transaction on the blockchain, even adding new users, needs to come from an originally authorized user. So I'm going to then submit this event and add a technician. So this is on the Ethereum network, as I had said. So this transaction actually needs to be mined or have the proof of work algorithm actually take hold of this transaction and commit it to the blockchain. So in just a moment, I should be able to be authorized on the smart contract and actually perform service on the vehicle. So let me refresh the page, and an error has occurred. Okay, there we go. So now, as a technician, let's say this vehicle, actually, let me grab a brand new VIN that this service center has never seen before. So let me grab a different VIN from a different service center. All right, so this is a valid VIN that's currently in the registry. Let's add some new service. So on this new page that you're seeing here, it looks like a normal Appian report, but there's something different here. There's a lot of information coming from blockchain, and so we actually added the Ethereum symbol next to every piece of information coming from blockchain. In a typical application, you probably should just leave those out, but we wanted to show you just how much information is actually coming from the blockchain. And so we see that the manufacturer was General Motors Company, that the mileage is currently 6,000 miles. There's 4 recorded events on this vehicle, so we've had lots of service already done. And so we can actually see the history of events that have been applied to this vehicle, even though we have never seen this vehicle before. And so we didn't have to prompt the user to go get your old service records or to basically have to rebuild that history. We can all just access it for free from the blockchain network. So as a technician, I'm actually going to go and add new service to this vehicle. And so this is going to be a normal Appian form. So I'm going to provide let's say some engine service because this car has been driving for the last 12,000 miles. We'll say it's some minor damage. And let's upload a document. So I'll actually upload a document which is going to be hashed and then stored in IPFS. This is the Interplanetary File System. It's a very unique name, but essentially this provides me a way of storing files in a distributed manner. And so there are a network of computers that will, upon me requesting for this file, will actually send me this proper file and only this file. And so this allows me to just store this hash inside of the Ethereum network. Since it's a publicly backed blockchain, it's expensive to replicate large amounts of data thousands of times over again. So a single gigabyte stored in the Ethereum network would be on the order of tens of thousands of gigabytes actually stored, which is why it becomes so prohibitively expensive to store large amounts of data. So I'm going to then hit next, which will allow me to go through and sign this transaction. So let me unlock my wallet. I'm going to sign this data, and so the signature is we'll take all of the data that I'm adding to the blockchain and sign it with my private key. And then when I hit submit, I'm actually going to send this information off to my smart contract, assuming that I don't actually have an error. All right, so I don't currently have privileges to upload this file to the server. That's my fault on the Appian side, not on the blockchain side, for not authorizing this user access to upload documents. So just real quick, bear with me. I'm actually going to, as a admin, actually upload a document. Actually, this looks like we actually have a transaction going through here, but let me add 600,000 miles, upload a document, and hit next. Unlock my wallet again, sign it, and we will then submit it to the blockchain. Excellent. So if we go back to our vehicles, I can then see that we've added this new service to this vehicle. So it's currently being mined, so we actually don't see it yet in the blockchain events. But locally, we can see that I added this service event. We can see who actually added the service. So this is something that's not exposed on the public blockchain, but rather it is being exposed to us. So I am an authorized user on my technician's smart contract, but I don't necessarily have to expose the fact that Austin Fathman performed this service on this vehicle. It's just going to show up as the Honda of Manhattan. So let me, and then I also, as I had said, I have this document, IPFS. It's just stored as a hash, but we actually have a link to a node, and this is apparently a very large CSV file that I uploaded. So I clicked on the wrong service documents, but if I open the correct one, it should open as an image. And then you should now that the transaction has been mined, we should actually see it in the blockchain events if I can get internet. No? All right. One more time. All right, so I should be able to open up. I see my appraisal form that I uploaded, and this is not coming from Appian. This is actually coming from a IPFS node, and you can see my very long hash up in the URL. This is what is stored in the blockchain, and you can actually view this transaction from a completely different node in the blockchain Ethereum network on Etherscan, which is the site for exploring transactions on the blockchain. And so you can see my transaction hash, and then also all the data. So I called add maintenance event sign smart contract, and this is all of my data that I committed to the blockchain, which I can then read back inside of Appian. And so if we go back, we can then see this. Oh, I am in the wrong tab here. All right, and you can see that this has actually successfully been mined, and it is now in the blockchain events. And if I were to go over to a completely different site, I can pull open this VIN and actually see the events in the event history. So there's no magic database happening here. This is all blockchain-backed information. So, to recap, take it over, MC.
To recap, so we started off asking the question, why blockchain? But we end with the question, why blockchain and Appian? Yeah, blockchain's cool, and that's probably why we came here today. I'm certainly enthusiastic about it. But businesses don't want to use blockchain because it's cool. Businesses want to use blockchain because it gives us an opportunity to introduce critical pieces of functionality that they need in order to be more successful at what they do. Right? We're a software company, and our main goal is to sell software and make our customers successful. An insurance company, their main goal is to sell different types of insurance policies and anticipate what the customer's needs are so that they can upsell them in different ways. The steel industry, they want to sell steel. Medical wants to sell medical. But there's a common bond between all of our customers. There's a common bond in all of the cases where we're able to be effective. That is that we're using technology. These companies are using technology to make their business more effective, whether it's faster, whether it's more innovative. They have multiple pieces of technology, diversity of technology, but they have a business process that extends across all of those pools of technology, whether there's a database here and a cloud service there, some SAP in the background, some sort of web UI front end. And they came to us because they said, we need a low-code BPM product that can extend across all of those technologies. Well, increasingly and soon, companies are going to be saying the same thing about blockchain. I've got a database over here, I've got SAP over there, I've got a third-party cloud service over there, and I've got some blockchain, and I need to connect this all into a cohesive business process. Or maybe we need to look at and manipulate data in some way, but that data doesn't necessarily exist in one place. We don't have a single source of truth for what it is that represents our customer, what it is that represents one of the commodities that we deal in. And we need a way to create a single pane of glass so that we can view all of that data at one time, regardless of where it is, in our on-premise backend system, in our third-party cloud service, or in a cloud service that isn't owned by us at all. We need a way to easily do that, and that's where Appian Records comes in. And increasingly and soon, we're going to be saying the same thing about blockchain as well. We need that single pane of glass to consist with blockchain as well. That's where Appian comes in. And the reason why I say it that way is, what we're doing now with blockchain is nothing new. We're just recognizing that needs to be a part of the overall picture and solution for our customers, and so we're trying to anticipate that. Austin?
No? Next. All right. And so we're not the only ones creating blockchain connectors. We also have some great partners. Both NavLabs and Luxoft have created some great blockchain integrations. NavLabs also created an Ethereum plugin, as well as Luxoft, who created a Hyperledger plugin. And so there are some great movements in our industry towards using blockchain within Appian. You really think of Appian as the coordination layer of adopting these new technologies and really just allowing you to add superpower to all of your applications. So whether you have a traditional database-backed application or a blockchain-based application, Appian's there to help you make it happen. So what's next? Email blockchain@appian.com so you can be notified when the Ethereum plugin is officially released. It should be in the next couple of weeks, or in the next couple of weeks after 18.2 has been released. So we'll be providing first the plugin to communicate with the Ethereum network, and then also with 18.2 some new features around the wallet design to make it even easier for your users to use. And then also start thinking about parts of your business where you can apply blockchain. Sometimes blockchain is applied in areas where it's more of a solution looking for a problem, but there are some great areas where blockchain can really fit in and actually add a lot of value to your application. And of course, you can always share your excitement with the Twitter hashtag or go on community and start a discussion. There's a lot of people who are excited about blockchain, and there's also some great resources. So yeah, if you have any questions, also reach out to blockchain@appian.com, or you can find us outside of this room after this, and you can feel free to ask us any questions. Thank you.
Thank you.